All right, here we go. Acid-base reactions. There are just two acid-base reactions that most chemists know, keep in the front of their brains. Here we go. The very first one is neutralization. Now, remember, a solution is neutral when we have an equal amount of hydrogen ions and hydroxide ions in our solution. That is because these two together make water. So if I had an acid and I were to mix it with a base, there would be a double replacement reaction that resulted in the formation of water along with some ionic substance, which is generally called a salt. If we look at this reaction in particular, I am mixing hydrochloric acid with sodium hydroxide. When I write neutralization reactions, I like to rewrite water as HOH. It just helps me to see the double replacement a little bit better. So here we have this hydrogen from the hydrochloric acid. It's going to have a double replacement with the hydroxide. If we were to write these A, B, C, D, A always pairs with D because it is a positive trying to pair with the other negative. And then over here, it would result as HOH, which is really water. And then the leftovers are the ionic component, which in this case is salt, but it could be any other ionic component. Now, when we have diprotic acids, remember diprotic acids are those that offer two hydrogens or two protons, di for two, protic for protons. These guys, because they have two H's, in order to neutralize, we would need double the amount of OH. So when I write my equation, the coefficient of 2 would need to go here. And it's, when you balance the equation, it turns out being this way. In order to get the balanced equation, a 2 would need to go here. But it's just something to keep in mind that when you have a diprotic acid, you need double the amount of base in order to neutralize it. And the same is true when I have a dibasic base. A dibasic base offers two hydroxide ions. Like in this case, we have calcium hydroxide. The calcium with its +2 charge requires two hydroxides. And in that case, I would need two hydrochloric acids in order to neutralize that. So for every one calcium hydroxide, I need two hydrochloric acids. That would give me two waters. And then this is my ionic component, calcium chloride. Another salt, just because it's ionic. And our last reaction, our second and also last reaction between with acids and bases, this one is particular to acids. If I have an acid and I attempt to react it with a metal, it will create hydrogen gas and then some salt. And this happens by a single replacement reaction. So we would have an acid, for instance, hydrochloric acid, and let's just say I took a dropper and I dropped it onto sodium. The sodium is going to steal the chlorine, creating sodium chloride and resulting in the formation of hydrogen gas. And that's it. It's pretty straightforward. That's all. If you take an acid and mix it with a base, you should get something neutral, provided that you have mixed the proper amounts. If you don't add enough acid, let's say, then you would have a solution that is more basic than acid. In order to neutralize, you have to have equal amounts of H and OH to form water. And then when we have an acid and we mix it with a metal, we get hydrogen gas. So if you have any questions, leave them in the comments and I will do my best to get back to you.